Hello, folks. So today I'm going to talk about, we're going to talk about microservices and monoliths. And we might actually be advocating for monoliths at KubeCon, but we'll see. So, clicker's not working.
We fixed this a minute ago.
I'm Goutham. I'm a Prometheus maintainer. I then started working on Cortex, which is another CNCF project, which is a horizontally scalable Prometheus, which is extremely microservices based. And then I also maintain Loki. And when I have free time, which I don't, given I maintain 3 open source projects, I try to bike.
Is this working now? My name's Ed. I also work at Grafana Labs with Goutham. I'm the tech lead on the Loki project. I try to contribute a little bit to the Cortex project. And I used to build Java monoliths. So we're going to talk to you about basically this order: monoliths, microservices, and microliths, which we just trademarked a couple minutes ago. So I'm going to give you a little bit of history about monoliths, and I'm going to tell you why they're the greatest thing ever. And I'm going to do that through this story about a pet walking service. So my friend and I decided to build a pet walking service. My friend is not Goutham in this case. He comes into play later. We decided to build this pet walking service, and like anything, we build a website, we build a back end, we put it all in one repo. It was real basic, real simple. We needed a proof of concept, and it wasn't a whole lot to it, right? So easy to develop, 2 of us working on it. You know, we had the journey onto our monolith, like the way most applications would start. Nothing really terribly complicated to, one team basically working, one person. Sorry, let me read my notes real quick. Easy to develop, single application. So we deploy our application. It's simple as well, right? We put it on one server. We have a simple MySQL database behind it. We pointed Pingdom at it. We pointed Nagios at it. Monitoring was easy. Deployment was easy. Updates were easy. Because we didn't really care about a lot of other stuff at the time, right? We didn't really care about high availability. We needed a proof of concept. We needed to make our dog walking service famous. But then things got a little more complicated. So we found success walking dogs, but then we found success walking cats, and we found success charming snakes. We were walking llamas. We had tons of customers all over the world. Our business was growing. We were backed up against a MySQL database, and we're doing all right. Like the monolith was still really nice, right? Like we had a code base we could develop from, one big repo. But we're starting to see people that are having conflicts about working on the same files, working in the same space. We didn't really build our app with snakes and cats in mind, so it got a little bit trickier. The deployment at scale got a lot harder. We started looking at Ansible to do scaled deployments, but we had trouble keeping our Ansible playbooks running. People didn't keep them updated. People didn't run them to completion. Every time I ran my Ansible playbook, I got a different error. I had to troubleshoot it. We're not really sure, like, how do we move from here, right? Like, database was getting a little bit trickier to work with. We had to use sticky sessions on our load balancers in order to do some kind of parallel scaling because our app wasn't really built to be stateless. Additionally, when I give this introduction to this talk to my manager at Grafana Labs, Tom Wilkie, he's like, how can you give this talk without talking about Conway's Law? I'm like, that's great. That's great, Tom. I don't exactly know what Conway's Law is. So went to Google, and I looked. I'm like, yeah, he's right. We have this problem, too. Our organization is developing into different business units. We have, sales. We have marketing. We have training. People have to learn how to charm snakes. Everybody wants something from our software, scheduling, and it's getting harder and harder to sort of, the lines keep getting blurred, the application keeps getting bigger, and we're really, really struggling, right? So, I open up the internet, and I look at it, and it says, I should move to microservices. So we went out on the internet, we posted a job offering, and we got this guy here.
So I was still in school, and I wrote a blog post that showed microservices were great, and they gave me VP of engineering, so I dropped out of school. And I was like, I'm going to microservices your world, man. And so if you look at it, microservices actually started taking off only in about 2015. It was just starting to take off. And I started implementing microservices everywhere. But like, why was I doing microservices? Well, simple answer, scale. Yep. It's just, we raised a bunch of hard bank money, and we scaled insanely fast. We added millions of users, and it's just this one monolith is not able to keep up with the scale of that we're adding. We're adding new cities, new pets, we're doing snake charming, all of that. But beyond all this, we did raise a bunch of money, so we can actually have more instances, we can have bigger instances, we can also still scale, because, of course, we are VC-backed. But it's not just that. It's just not scale in terms of throughput. It's also scale in terms of organization. It's like, as Ed was mentioning, there's now a sales team, there's now a marketing team, there's a training team, billing team. There's a team for everything. And they were all working on the same code base, and the code base was becoming bigger and bigger. There were like 5 different apps for different things. It was all running off a single code base. We were trying to release every week. So we cut a release on Monday, and by Wednesday, the snake charmers couldn't snake charm anymore, so we had to roll it back. It was just getting super untenable. Everyone was trying to get their features in. Nobody was trying to test their features, and everyone was blaming everyone else. That didn't work out, so I was like, I'm going to split this organization into microservices, one for each team, or a set of microservices for each team. So billing gets a microservice, snake charming gets a microservice, dog walking gets a big microservice because they're the most popular. Everyone gets a new microservice. I'm like, you got a microservice, you got a microservice. And in the end, we ended up actually doing pretty well. We hired smart people, and everyone was taking care of their own microservices, and it was kind of sort of working. And then it actually got out of hand. We had a small microservice that was doing addition. Like, yeah, if you look at the real world, actually, it's kind of sort of true. If you look at Monzo, that is their microservices path. So apparently, if you use Mongo, you actually are going to hit 1,500 different microservices, which is insane and awesome. But I was like, oh, this is too much. I'm going to go back to school, finish my degree. This is not for me. And I actually went back to school, graduated, and I joined Grafana Labs. Sorry about that. Yeah, and I joined Grafana Labs. And when I joined, I was going to work on hosted Prometheus, which is a CNCF project called Cortex. It is a pretty simple application. As you can see, it just has 7 or 8 different microservices. I was like, I snake charmed before. I can do this. I can work on Cortex. And I was like, let me see how to contribute to it, how to build it. Run make. I can run make. Run make test. I can do that. And then it said, run minikube, and then run all of these different services and stateful sets, all these different things in minikube. I'm like, wait, what? I'm in college with a 4-year-old laptop, and I need to run minikube. Wait, I need to run Kubernetes on it, and then put 7 or 8 different applications on it just so that I can run a simple query called up. What is even happening in this world? It was super confusing. But anyways, as I said, I was pretty smart. I actually ended up building and working on it, and a month or 2 later, I went on call. That was fun. It's like, oh, queries are slow. I'm like, okay. I had no clue what to look at. There was like 8 or 10 different things I need to look at. What logs do I look at? Do I look at all of them? Do I look at some of them? Why are we logging at debug level? What is this new distributed tracing thing? It was just getting untenable, and I actually wanted to go back to a monolith where everything is in a single process. I can easily debug everything. I know what's going on, and all the logs are super clear and in one place. And that's when I read this amazing blog post by Segment. That's a really good engineering team, and this was right about the time I was getting super frustrated. They're like, from 100 problem children to 1 superstar. And I was like, yes, this makes so much sense. Like, wow. And then I noticed something else. The rise of the mono-microliths, or micro-monoliths. So I think that these applications are the future, and they're amazing. So what are they? I did not do that.
Nobody look.
Shit. Anyways, so a monomicrolith is a single binary monolith composed of microservices. What do I mean? So basically, let me give you an example of a very popular CNCF project called Thanos, which also does hosted like scalable Prometheus, but with different trade-offs. The thing that I love about Thanos is how simple it is to use. So essentially, you have your Prometheuses in different clusters. You want long-term storage. You want to aggregate data between your different Prometheuses. You can use Thanos. You can also use Cortex. So basically, you first start running a sidecar with your Prometheus. And then the sidecar by itself does nothing. So you need to add a courier service to it. So this courier service talks to these sidecars, talks to Prometheus, and makes sure that it aggregates data from different Prometheus servers. It deduplicates data if there's HA pair, Prometheus pairs. So the first step is, OK, I want global aggregation between my 3 different Prometheuses in 3 different clusters. You add the query layer. And then you can decide, hey, this is not enough for me. I want long-term storage. You add the object storage layer, which uploads these blocks into the object storage. And once you're happy with that, you add the compactor layer, which actually lets you compact these blocks in object storage into bigger blocks. The thing I really, really like about this is it gives you incremental value, and you can start with something super simple that you understand, and then you can add one more component that you understand, and then one more component, and you can come up with a much complex architecture. And when something breaks, you have confidence that you can fix it because you actually grew from a small app to something more complex. You gained confidence there, and then you went to something more complex, which is amazing. And we realized that this is the user experience. This is the developer experience we wanted. Thanos is a single binary. Just to go build Thanos, /Thanos, and you have Thanos working on your local system. And we attempted to do that with Loki. It was super successful. Like, Loki has been adopted mainly because it's super simple to use. We don't need you to run 20 different microservices, just one binary. And we went back and re-architected Cortex to be simple to use. So if you go and look at the Cortex README right now, it looks like this. Go build Cortex, /Cortex. That's as simple as it is. And most of my time, I'm not running on Kubernetes anymore. I'm just like doing most of my stuff locally and then pushing to dev in a different, much bigger Kubernetes cluster and testing it at scale there. The development experience completely changed, and I have a lot more confidence in Cortex now. You will see why. But Cortex, Thanos, Loki are really good examples. Similar example is Jaeger. You can just start with the Jaeger all-in-one binary, run all of Jaeger as a single monolith, and the moment you realize, OK, Jaeger all-in-one is not scaling, let me scale the ingest path. You can run a bunch of queries alongside your all-in-one, and then a bunch of collectors, and then you can also add a bunch of query Jaeger pods. Slowly, you can grow the complexity of your Jaeger application. Similarly, I've heard Elastic is the same. You can independently scale the query path and the ingest path. So these are really good applications that have seen incredible adoption because they are monomicroliths. So Ed is going to now talk about what it takes to build a monomicrolith.
So I fast forward now. I've given up on dog walking as a career, and I end up at Grafana Labs, and I start working on the Loki project. And right out of the gate, this is kind of new to me. So this is a single binary application that we have the ability to scale horizontally. And as this project has grown, this has seen a huge amount of success because it has a really low barrier to entry. But it has a lot of other benefits too. We're able to run the application locally. I can run it from my editor with a debugger. It's like all the things that I loved about my monolith, but I can still have the ability to scale horizontally. So I looked at the code base, and I've kind of tried to summarize, like, how did we get here, right? Like, what makes Loki, what are the kind of core components to building an application that has this functionality? And the probably first important part is a modular code base. Kind of an old word in software, right? Modular code has been around for a long, long time. Books have been written in the 60s and 70s, and there's nothing really new or fancy about it. And we're all supposed to do it, and it's kind of hard, right? Like building a application that's modular is not necessarily hard, but knowing where to draw the lines of modularity is. And so, one of the things that I think that makes sense in the world of horizontal computing is to build modules around how your application scales. So Loki and Cortex are database applications effectively, so we heavily modularize the read and write path so that they're isolated and they can scale horizontally separately. If you do a lot of heavy calculation, processing, scheduling, like if you have workloads in Kubernetes, those are generally good module boundaries to define. Another sort of really valuable aspect of the modularity is how you do config management. So all this kind of ties together with a single binary concept, but you have a composable config object that's made up of all of the config objects of each module. So for Cortex, it has a querier, ingester, storage, all these different layers. They keep their configuration within their modules, but we pull all that up into a composed config object. And we do that because that's what allows you to do this /cortex run with a single file. The single config file contains the config for all of the different modules. And similarly, this is the single binary aspect of this, which is kind of a really important part for that ease of use, that ease of entry experience. This is what lets me run this on my laptop with /cortex. What lets me run my debugger again. I'm not installing Docker. I'm not running from a Docker container or trying to attach to a remote process. I'm not running an app server and then trying to attach to that. I just have a binary and a config file. And then when I get to the point where I'm actually ready to scale my application out, we manage that through config options. So there's different arguments that get passed into the same binary, and effectively, internally, we just load the modules from the code that we care about. In case we target it to be an ingester or a distributor, these are terms related to kind of Cortex, but it's about reading and writing effectively. And we can add these components as we need to. And the modular codebase, if you notice, is still using the same, in this case, Docker image, because we just wrap that binary with one image, and the same config file, because we're loading the same config into everything, and they just read the sections that they care about. A big part of what enables this, at least in this case, and there's a few ways to do this, but gRPC is a fantastic way to sort of enable this modularity to go horizontal. So a couple things that make gRPC really, really good for this is the interface that it defines. I was a big fan of SOAP back in the day, and I'm going to get laughed off the stage for it, but I love WSDLs. One of the things I loved was the WSDL, right? Like we moved to REST, and the REST had a waddle, and it was just never the same. And gRPC kind of reintroduces that feature that I really liked, which is this contract, and it's an interface. And inside of let's say Loki, for example, because I'm more familiar with that, when we load these modules in the single binary, we're still using gRPC. We just effectively, at least in Golang, we register the handlers, essentially the paths for the handlers are separately, even though they're loaded in a server and localhost. And so when that process runs as a single binary, it effectively makes gRPC calls to itself on localhost, on a local socket. I'll point out that this is not obviously the most effective way to scale an app, right? Like you're serializing and deserializing to the same process. You have duplicate memory in places, but in the bigger picture, we don't really care that much, right? Like the idea here is ease of use, right? Like I want to be able to run it. I want people to be able to run it easily. I want to be able to debug it. When I want to scale it because I'm running out of limits, that's when I start going horizontal. Another aspect we call is kind of airplane mode. So in terms of good application design, it's really, really a good idea to abstract all of your what I call third-party dependencies through your own interfaces. In this case, DynamoDB or S3 or anything that you have that you're writing to or you require. And the airplane mode concept is that you should be able to run your app without internet access or with really, really poor internet access. If you have a dependency on an API or a third party, abstract it through an interface, and then make a simple implementation of it, something that writes to the file system or something that produces data that you can configure. It's worth the time because this really speeds up your ability to sort of develop this app. And in the case of both Cortex and Loki, they have a file system storage for both the object and the database store. And it's not super performant. It's got its limits of scalability, but it kind of doesn't matter because it just lets you run the thing. Like I don't need anything, I don't need to connect anything, I don't need to set any accounts, I just run the thing. This is the monolith world that I really missed, right? Like the ability to just do something without having to have 10 different microservices and run them in containers and getting them all set up. Another thing that I would say is a little on our opinionated side is the mono repo. Loki, Cortex, Thanos, these are mono repos, the client, the server, all of the pieces, everything, plugins, third-party stuff, we just keep stuffing it in the same repo. It's been making our life a lot easier, and there's kind of a few reasons I think that helps. One, in the modularity sense, in my experience, is when I took a Java app and I decomposed it into a bunch of microservices years ago, I put them all in their own repo, they all had their own Maven coordinates and files, and what I tended to find is like over time as an application evolved and that interface changed and it got to the point where I'm like, okay, this should really be 2 separate modules. I didn't really feel like setting up a new project. That was a huge pain in my butt. I had to make a new source control project. I had to configure a new Maven file. It's a lot of copy and paste and like I just didn't do it, right? So keeping that code in the same code base and limiting the sort of effort required to refactor your code base is a big advantage. It's a big advantage for sort of consistency and tagging. Put a different way, it's hard to see the advantages of breaking these things up into separate repos. So we get back to the Cortex story here, and essentially Cortex went from this microservices application and following on the success of projects like Loki and Jaeger and Thanos, we've re-architected it basically to operate in this this single binary but scalable approach. And it ends up working where you can run the thing, you connect it to your database or your file system in this case. Then, when you want to run more of them, you can actually scale the single binary horizontally. There are some caveats in the Cortex and Loki case for that matter too, where scaling up and down and some of the communication is still a work in progress, though it is possible. It's better if you point it at some kind of a shared cloud storage or local storage like Cassandra or Dynamo or S3 or Bigtable or all of those things. And that's part of that abstracting your storage interfaces or any of your external through your own interfaces to make sure you can swap these things out. Come on, buddy, you're almost there. So, yep. And then you get to that point again where it's like, okay, now my monolith works great until it doesn't, right? And that's where you start breaking things up. But to Goutham's point, like I can run the thing and be confident in it, and I can point people at it, I can point new developers at it, they can use the thing, and then when I get to where I'm deploying it, at the big data scale that I want my company to be at, I can add these targets and configure the services and scale them horizontally. Did you push?
Yeah.
Nice. And then we can add other services like the front end, and then ultimately we get back to this architecture that we have here, which is what we really want. Microservices, in many ways, really are the way we want to be in a Kubernetes environment and a cloud-native environment. It does work really, really well. It solved a lot of the problems that our pet walking service had. It just also created a lot of problems that were already solved, right? Like, the development experience, the onboarding experience, and the, proof of concept type experience. So in the end, at least we're proposing here with, some of these kind of ideas of these projects, you can effectively have your mono microlith. We're working on that still. But you can have your application be sort of both of these things. You're making some trade-offs in like how performant it is in one direction or another, but it gives you a lot more flexibility.
Yep. To summarize, being like having a monorepo is super nice. It helps you actually build this single binary that you can do /Cortex, /Prometheus, and it all works. Having modular code, gRPC, all of this is great, but always remember, like when you're onboarding new developers, make it easy for them to run stuff. If someone's coming onto your team and you tell them, hey, you need to run this 17 different services, in Kubernetes, in your own namespace, to do any kind of development, you need to build an image, push an image. You do all of this, they're going to quit. And don't make them do that. Make the development process super easy and make the adoption process incremental. Like, let people incrementally add complexity as they need. And if you do that, things will change. If you have an open source project, make sure it's easy to use, and it's incremental when you're scaling it out. And once we actually moved Cortex from a microservices to a mono-microlith world, the number of blog posts, the adoption, the users, everything just shot up. And it actually, it matters that you make the development experience and the adoption experience super seamless. Questions? Okay, there's a bunch of questions.
Yeah, if you can head to the mic, that'd be great.
Susan, two quick questions. Like, how big are the teams here? Because part of why one might do separate repos and do this is you just don't have disciplined engineers that are capable of working the way you're talking about, but you still need to make progress. Could you talk to those things?
So in terms of like a mono repo, I mean, if your code is modular enough that your teams are disciplined, like it shouldn't, in theory, matter what repo you're in, right? Like if you're committing into different files, like if you're all working out of the same file, I would say maybe you've got to look at how your code is architected so you can break it apart into files where people aren't colliding. Generally, the source control doesn't really care how big it is if you have enough ability to keep people out of the same place at the same time.
Well, I think the question is more, so these teams that are working on these mono-microliths, how big are these teams?
These teams are actually super small, at least the open source projects that we're working on.
Yeah.
But
I guess the question is, what would it matter?
Well, it matters to communication and discipline and how they understand what they're doing. With a small team, it's quite easy to understand what you guys are talking about. I'm not criticizing, I'm just saying there's this thing of artificial force boundaries to help people be more disciplined where they don't cheat across modular boundaries. That's what I was wondering about.
Next question.
So I'm not 100% clear on what you're advocating for, but what it sounds like is you're saying build your code in a modular way, almost as if it was a microservices architecture, but in one place. And then because it's so modularly built, you can easily break out a microservice if you have to down the road. Is that what you're saying?
Yes.
Okay.
And make sure that it's easy to run it locally as a single process, single binary, so that people who are new to the code base, they can quickly run it instead of and they can debug it by hooking up a debugger locally instead of having to hook up the debugger up to a Kubernetes cluster.
Okay. So at the time when you do break out a microservice, would you put that in a different repo?
No, I would actually, so as Ed was saying, it would be like /Cortex, target querier, target ingester. It would be in the same binary, but with a different flag or a different command. It could be Cortex ingester, or Cortex querier, or Cortex all-in-one. So the new microservice will still be in the same repo.
Okay, thank you.
So you've taken a microservice architecture and turned it into a single binary. One of the benefits of microservices is how easy they are to scale. And I wasn't quite clear on what you were doing to make that single monolithic binary that you've now deployed to Kubernetes or wherever scalable in the same way that microservices are. So we are not going to scale the single binary. So essentially, if you can, let me just go back.
I don't know which one you want.
So if you look at this, you can just start with running all the components in just in one layer, and the moment you suddenly notice, oh, queries are a bottleneck now, and I can't scale this out without affecting other things, let me just break the queries into a separate microservice just by adding a new command, /Cortex target querier, and then this is a new microservice that just does querying. And then, oh, queries are not fast enough. I need to add some caching, parallelizing, splitting, munging. You can add a front end, which is another microservice. So you can incrementally add this complexity, and you can incrementally add microservices as you scale. So
the way that actually works is just the argument on the command line. So when that initiated that module, the argument on the command line determines essentially how many gRPC endpoints you register, what code is initialized, et cetera. So there is some kind of glue work up front that determines how many of those modules are actually active in that binary in order to determine what kind of microservice it is.
Okay, thank you.
Conceptually speaking, this is like super interesting. You're drawing this wonderful third camp that we can all pitchfork against, and you seem to be advocating for like some sort of boundary line between like the monolith and microservice purism ideals. But what would your guiding principle be of like how to draw the lines between where you need a totally separate service or a separate repo? I'm sure there's separate debates. What guiding principles would you just come up with based on your experience of, okay, that's probably time to start a new command to run completely separate?
So, I mean, we're bounded by an application with kind of a purpose, right? Like if you're architecting, I think, something more like how would you run your business, right? Like back to our pet walking business, right? Like, you know, I don't know that you need to be, I don't know that the limitation needs to be the source control. Like you could put all of your code in one repository. Companies do this. The advantage of that, I think, is it does make it sort of simpler to kind of move around what makes, would you run an entire company with one binary? I don't know that, I mean, I guess you could. Like, I don't have a great answer for, I mean, this is why the modularity problem is hard, right? Like again, I would just kind of look back to say, like, what is the scalable unit of this? And like, and back to Conway, you know, like, what are my business units centered around? And, you know, what are my teams focused around? I mean, I don't think there's a limit to how big you could make this. I don't know that there's an advantage to making it infinitely big unless you regularly have people moving all over the company and all over your teams and all over your code base.
Kind of the same problem of like, what is a pod and like how big do you make it and what do you put in it and all that stuff? The modular set.
Yeah, I mean, generally speaking, the smaller your modules, the better, right? The smaller the interface, the better. You know, the smaller you can make any composer. This is the microservice idea, right? Like the smaller you can make that, the sort of, in theory, the easier it is to do rollouts, the less likely you're going to make changes, the easier it is to test. So, you know.
Thank you.
Yep.
You have time for 2 more questions.
Hi there. Quick question about moving from a monolith to a microservice structure. How did you, I guess, maintain progress over, you know, weeks and years of, you know, keeping your monolith running, keeping it maintained, putting out new features while simultaneously, you know, migrating it into a microservice structure? How did you, I guess, keep progress going instead of, you know, stopping and never getting back on the project?
We cheated by having a small project that.
Fair. Any advice that kind of like really helped you guys stay on track?
I mean, I guess like depending on how your code base is built, if you can continue, like if you can pull out functionality, start it as a new service, start slowly migrating people to that service and sort of continue that trend, like sort of define where you want your modules to be, like what your business units are, start pulling functionality. You're going to basically be replicating it at some point, right, until you can decompose your app into. Unfortunately, I don't know that I have the. I imagine there's a talk out there on how to decompose your your monolith, but.
Strangler pattern. Okay, so no magic pill. Okay, thank you.
Do you think there is a way to integrate third-party services into a monolith binary?
Can't quite hear you, I'm afraid, sorry.
Like, is it possible to integrate Redis or Postgres into a monolith binary?
Integrate them into it? I mean, I would consider those like the external dependencies, and I would abstract those through an interface. Or more like, in a Postgres sense, like, it's trickier if you're using, you know, lots of, like Cortex and Loki abstract through reads and writes, simpler interfaces. I mean, it's not that simple, right? But if you can build your application around the units of like what you're storing and how, so that you can implement any storage mechanism behind them, that certainly makes that easier to hide those out. Like, that being said, like, if your app, like in the old monolith days and the original story, like if your only dependency is running something like Postgres, you can run that locally pretty easily, so that's not a huge barrier to entry.
And I would like to add that we use DynamoDB and Memcached or Redis in Cortex, but the single binary no dependency version has in-mem caching and BoldDB as an alternative. So you could implement an interface into SQLite, Yeah, and then have everything run locally without having to run this Postgres. And this is only for development or for quick testing to check if your code works and all of that. So you can always abstract that away with a no dependencies version.
Okay, understandable.
Thanks. Let's give the speakers a round of applause, and please fill out your breakout session.